Good evening. Today we are going to see now the third part of the oral questions. In this, we are now with columns. We have seen first that is slab. Second, we have seen that is staircase. And now third, we are with columns. And questions will be asked from these only. I am going to make the cheats of the questions which are in these videos, and you have to take the cheats and answers the questions. What are the different types of column considering loading? So already you know we are with three types of columns. We solved the problems. One is axially loaded column. Axially loaded column. Second, we are with axial load plus uniaxial moment. Axial load plus uniaxial moment. And third, we have axial load plus biaxial moment. Plus biaxial moment. Now, where we have these columns, when you are explaining these types, you can draw a plan in this. And by this plan, you can explain these types of columns. So let us, we have this plan, and in this, we can say that the column with beams on all sides with approximately same load, this becomes your first type, axially loaded column. Now the column which are on boundaries but not at corners, we have boundaries not at corners are axial load plus uniaxial. So this one. So interior columns are generally we are with axially loaded. Columns with which are at periphery but not at corners are going to be your axial load plus uniaxial moment. Why? Because moment due to this beam is balanced by moment due to this beam, and we have this moment that is unbalanced. Now inside all columns which are of first type, reason moment of this beam balanced by this beam, moment of this balanced by this moment. Means I will say moment of beam A balanced by A dash, moment of B balanced by B dash. And therefore no moment will be there. And at all corners of periphery, we have axial load plus biaxial moment. And the reason, because bending moment due to this beam and bending moment due to this beam, that both are unbalanced, and corners, all corners, we are with third type, axial load plus biaxial moment. So we have to design these three types of problems on a column in our syllabus. Now, what is the difference between PUZ and PU? PUZ, if we will say, it is purely axial load. Purely axial load means my bending moment is zero in this case. Now, what is formula for PUZ? So we have 0.4 FCK AC plus 0.75 FYASC. Now we can modify this. I can write point AC, that is AG minus ASC plus 0.75 FYASC. And in this first term and second, 45, this is not 0.4, it is 0.45 FCK AG is gross sectional area, gross cross sectional area, and in bracket 0.75 FY, and we have this will be 0.45 FCK ASC, but with minus sign. So we have taken ASC common. So we are being with this formula. So this is for purely axial. If we will go with PU, this is axial plus minimum moment. Minimum moment. And we have that is 0.05D or likewise. So that is with minimum moment, and your value of PUZ is being decreased to consider the stresses due to moment, and that decrease of moment is 11%. So we have 11% which is decrease of moment. Decrease of load capacity, decrease of capacity by 5%, and that is to accommodate the stresses which are developed due to the movement. So we have this PU zero point 0.4 FCK AG plus 0.67 FY ASC. So this is the difference. We have the coefficients with FCK AG and FYASC are reduced by, not 5%, these are reduced by 11%. So you can multiply 0.45 by 0.89. So you will get 0.4, and 0.75 by 0.89, you will get value 0.67. Then explain the formula for biaxially loaded column. So we have this formula MUX upon MUX1 to the power alpha n MUY upon MUY1 to the power alpha m less than equal to 1. Do not write m dash ux upon mux likewise. So many of the students written that formula in that fashion. Formula should be as per IS in your problems also, which you are going to show tomorrow. So now here you can see MUX and MUY, these are moments about X and Y axis due to design load. So these values are external moments or values developed due to external loads. So these we are using this MUX, that is WUL square by 12, and same MUY, and we are getting these values of moment due to external loads. And this MUY1 and MUX1, try to understand, this is moment capacity. This is moment capacity. What is mean by moment capacity? So this is property of the section. This is property of the section. That is strength of the section. Property means, capacity means strength of the section. And these values we have to calculate by using PUMU. We have two methods, analysis method and PUMU interaction curves. So we are going to use PUMU interaction curves. So this we are going to use to find value of MUX1 and MUY1. Then next part we have alpha n. So alpha n that is given. So for which we have to find PUZ, and then we have to find PU upon PUZ. PU is given to you. So PU value is given. So PU given, PUZ you have to calculate, and then you will get alpha n. Now how we will get alpha n value? So there you can see we have these values that are given. So you read it. So that is given. Here this is given. PUZ 0.2 to 0.8. Value of alpha n varies from 1 to 2, and for values less than 0.2. So I already explained in the class So we have this value constant, which is 1, value of 2.2. On this we have pu upon puz, and on this we have alpha n. And then this value get increased and it becomes 2 for pu upon puz, that is equal to 0.8, and after zero point 0.8 this value is constant. So if your value comes below 0.2, then your value of alpha n is 1 if your pu upon puz is less than 0.2. Your value should not be less than 1 alpha. And how we are finding this value? Suppose my value of pu upon puz, this value is 0.6. Formula I should know. How we are going to find? So we have somewhere this line will go, and we have this will be similar triangles. In these similar triangles, this is 0.8 minus 0.2, and this is 2 minus 1. And 0.6 is somewhere here. So here we have 0.6 pu upon puz. So this is y. How we will get this value? So we have to add this 1 in this. Means if I will draw over here, so below this we have 1, which is till 0.2, and this y value we are going to calculate by using similar triangles, and then I will get alpha and 1 plus y. And how we will calculate y? That is by similar triangles, which is equal to 2 minus 1 upon 0.8 minus 0.2, and then we have this value. Here you can see this. So this is 2 minus 1, and then we have this y. And what is this value? So this value we have 0.6 minus 0.2, because it starts from 0.2, means whatever value you have of pu upon puz upon minus 0.2. So we have these values into, we have to multiply it by, so multiply this into pu upon puz minus 0.2, because it start from 0.2, and therefore we will get the value of alpha n. Likewise, we have to check the capacity of the column. Explain pu-mu interaction curves. Already we are with this in the class. So we have this pu-mu interaction curves. What terms we have in these curves? So you can see over here. So we have on y-axis pu upon puz, and in along x-axis we have mu upon muz, and all these curves are p by fck. Start from 0, and we have maximum value. If we will see, we have this value something 0.26. If my value of p by fck, if you are getting out of this, then you have to revise the column. You cannot go with this same column. That you have to keep in mind. Now, if you will calculate pu upon fck bd, then you will have this pu you have in Newton, fck Newton per mm square, bd we have mm, and d also mm, and this mm gets cancelled with mm square, Newton gets cancelled, and same with your mu we have in Newton meter, and then below Newton millimeter, and below we have Newton per millimeter square, which is FCK. We have B, and then we have D. And here again, every FCK B D square. So this is square. So mm cube, it will go up. So this is mm square, mm cube get cancelled, n get cancelled. So we have these charts are coefficients only, unitless charts we can say. And then we have to solve this. Now to select the chart, what is required? First we required Fy value. Second we require d dash by d value. And then third, you have to see what steel on opposite side. steel on opposite side or on all faces, or on all faces. So by using this, you have to select the chart to solve the problems. Then we have explained use of PU-MU interaction curves for axially loaded plus uniaxial. So in this, we have three values. One is PU upon FCK BD. Then we have MU upon FCK BD square. And third, we have P by FCK. We have these three terms, and out of these three, two values are given. Two values are given. It may be PU upon FCK BD or MU upon FCK BD square. Then you have to calculate P upon FCK. If you have given P upon FCK, PU upon FCK BD, then you have to find MU upon FCK BD square. So you have to check it. And what is D dash by D? If you have bisecting depth, then you have D dash by D. If you are bisecting width, then it is D dash by B. And if bisecting depth, then your formula will be mu upon FCK BD square. And if it is bisecting width, then you have mu upon FCK B square D. So that is most important. Is it bisecting depth or bisecting width? Then we have explained PU-MU interaction curve for axially loaded and uniaxial moment. So already in that formula we have seen we have MUX upon MUX1 to the power alpha n plus MUY upon MUY1 to the power alpha n less than equal to 1. So MUX, MUY, these are given values, or we are going to calculate by using external loads, and then we are going to calculate. So in this, you have to assume P by FCK. And then we have PU upon FCK BD. So now these two values we have, and then we have to select chart. Suppose we have to find first MUX1. Then we have P by FCK and PU upon FCK BD. This is fixed for both. Then you have to find D dash by D, where D is depth. So, and then other, that is Fy, still on both sides. And from this, you have to select the chart, and from which you will get value of MUX1 upon FCK BD square. And then that value, that some coefficient you will get, let we have 0.19, and then we can find value of MUX1. Now to find MUY1, student are selecting another value of PU upon FCK-BD. So in this also, your P by FCK will be same as your above value. PU upon FCK-BD, again you have same. Then what is change? We have to use D dash by D instead, D dash by B instead of D dash by D. Then again Fy did your steel on both sides or all, that you have to check, and then you will get MUY1 upon FCK B square D, and that latest we have some value 0.12. Here we have B square, here we have B, whereas here we have D, and in this we have D square. So that change you have to see when you are solving the problems. Then axial load, this already we are in class. One problem we have solved. Suppose we have somewhat plan in this fashion. Then how we will calculate the column load? So we have, this will be my plan. Then to find, we have to go to divide this all slabs, that is in 4 parts. So we are going to divide this in 4 parts. So whatever quarter we have nearby that column, that load will be shared by the column. So this area load will be shared by your column. Then we are going to find out this area. Then we will find slab load multiplied by this. Then length of wall. So we have length of wall and beam we have same. This is L1 I will say. Then we have this will be L2. Then we have L3 and then we have L4. So likewise taking length of beam, then area for slab and then same length of beam as length of wall, we are going to find total value and we are going to increase 10% for unforeseen forces or conditions we can say, and then we will get value of pu, and then by using minimum eccentricity we are going to use this formula, and by using this formula we are going to find out value of ASC. If your column load is less, then you will get ASC value that is negative. If you will get ASC negative, then you provide minimum reinforcement that is 0.8% of AG. If your value you will get, you have to check your value of ASC with minimum. If it is less than minimum, means if you got value as ASC 500 mm square, then in that case you have to check AST minimum, and if it is 600 square, then you have to provide maximum of the two as minimum reinforcement. Then what is difference between actually loaded rectangular and circular column? In a rectangular column, we are going to provide lateral ties. And in case of circular column, we are going to provide helical reinforcement. Generally, it is known as helical reinforcement. Considering these ties, we are in this fashion, and then we have to check this circular column for the condition given in IS code, and if that condition that we will see in the next question satisfied, then we have to increase capacity by 5%. So you can see this. So this condition is given: volume of the core shall not be, sorry, volume of helical reinforcement upon volume of core, and that value should be greater than 0.36 Ag upon AC. This is AC is area of core into FCK upon Fy. If satisfied, then your value of Pu is 1.1, 0.4 FCK Ag plus 0.67 Fy minus 0.4 FCK into ASC. So that, sorry, 1.05. So it is increased by 5%. You can read over here 1.05 times. So that value is increased by 5%. So it comes 1.05. So same that I have explained, but you should know these terms. So if that is asked volume of core, so if asked, then you should be in position to explain volume of core upon volume of, sorry, volume of helical reinforcement upon volume of core. So volume of helical reinforcement, we know how we will calculate this. So this we can calculate, that is area of helical reinforcement multiply by its length. So that we should know. So we have this will be length multiplied by area. So I already explained, I will not make this video lengthy. You can go with this. But we have taken problem in the class also for this, and volume of core, that is the concrete between the two helical reinforcement. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.